Hello, fabulous fifth graders, and welcome back. Today we're going to work on multiplying decimals by other decimals. So I know last week we had worked on multiplying decimals by whole numbers, and this week we are going to work on multiplying a decimal number with another decimal number. So let's start with a little review. When multiplying a decimal number by another decimal number, you can use the same process as before. So whatever we did before, you can apply it. You're going to ignore your decimals for the time being, and you solve your problem as you normally would with the whole numbers. At the end, before finding your final product, you need to use your number reasoning and place the decimal back into your answer. So it's going to be really important to use estimation, right? So you're going to be thinking about it as scooping your decimal to the right to make them whole numbers initially. And then at the very end, when you're done multiplying, scoop the decimal place back on the left the same number of times you had to move it prior. Estimation, as I mentioned, is going to be key because it's going to help you place that decimal in the appropriate spot in case you're unsure. And it's also going to help with your reasonability to make sure that you're on the right track and you've scooped appropriately. So let's see one in action. If I have 4 3/10 times 57 6/100ths, what's that going to equal? So my first part, I'm going to set up the problem as I normally would, as if they were whole numbers, ignoring the decimals for now. So 4 3/10, I'm just going to make that 43. 56/100ths, I'm going to think about that as being 56. So in my head right now, I'm thinking about multiplying 43 times 56. So my second step is to multiply 43 times 56. So I'm going to multiply that. I have 6 times 3 is 18. Carry my 1 over. 6 times 4 is 24, plus that 1 more gets me that 25. So my first partial product is 258. I put my 0 placeholder. I multiply 5 times 3 to get 15. Carry the 1 over. 4 times 5 is 20, plus 1 is 21. And I'm going to add up my two partial products, and I get a grand total of 2,408. But here's where we need to stop and think. I am not in reality multiplying 43 times 56. I am multiplying 4 3/10 times 56/100ths. So I need to go back and think about the decimals. So I'm going to count the number of digits in the decimal place values of my original numbers. So in 4 3/10, I had one decimal digit, or digit after my decimal, I guess I should say, one scoop to the right to make it 43. For 56/100ths, I had to scoop twice to get that to be 56 as a whole number. So I ended up scooping once in the first number and twice in the second number for a total of 3 scoops in order for it to get to 43 times 56. I had to scoop 4 3/10 and slide that decimal over once to the right. And for 56/100ths, I essentially slid the decimal over twice to make it 56. So I now need to go back into my answer and slide the decimal back in 3 spaces. So I'm going to take from the very left, go to my product, count and scoop that many places to the left of the last digit. So I start at the 8, and I need to scoop 3. So I scoop 3 places, and that's going to put me at 2,408 thousandths. So I counted the total of place values that I had digits in the decimal, 1 in the first number and 2 in the second number. And then I go into my answer to my multiplication product, and I need to now just scoop it back over and place it where it belongs, 2,408 thousandths. Here comes the important part. Think about reasonability and estimating. So my last step is to kind of go back and see if my answer is reasonable. Well, thinking about my estimate over here in the corner. 4 3/10, that's pretty close to 4. And 56/100ths, well, that's pretty close to 1. So I'm thinking about like 4 times 1, and my answer is 4. So is 2,408 thousandths close to 4? Yes, relatively speaking, right? If I'm thinking about where the decimal is going, it can either go in front of the 2, behind the 2, behind the 4, behind the 0, or keep it behind the 8. We know we don't want 2,408. 24 and 8/100ths is not going to be a logical answer, or 240 and 8/10ths not going to be a logical answer. So as much as 2 and 4 might not seem very close, they're both in the ones place, which is what you kind of want to be thinking about as well. So it does make logical sense, and so that's a good one. Okay, so here are the steps kind of to review what I just talked about. The first thing you're going to do is you set up your problem as you normally would, making them whole numbers and ignoring the decimals for now. You multiply as you normally would. When you're done multiplying and you have a product, stop right there and figure out what the actual product is going to be. So you need to stop and count the amount of digits in the decimal places of your original numbers. So going back to our example, 1 and 2 for a grand total of 3. We had 3 digits in the decimal place values of our original problem. I need to take that thought of 3 digits in the decimal place values and go back to my answer and scoop that many places. I start at the very end of my number and I scoop however many times I need to left. And in our case it was 3. And then it's so very important that you estimate to see if your answer is reasonable. Okay? So important. Let's look at one more and then you will be free to practice. So 51 and 6/10ths times 3 and 9/10ths. I'm going to ignore the decimal and just multiply. 516 times 3 and 9/10ths. So I'm going to do 9 times 6. I have 54. Then I have 9 times 1 is 9, plus 5 more is 14. Carry that over. 9 times 5 is 45, plus 1 is 46. There's my first partial product. 0 placeholder. 3 times 6 is 18. Carry the 1 over. 3 times 1 is 3, plus 1 is 4. 3 times 5 is 15. Place that down. Add up my 2 partial products. And I get 20,124. Here's where it's super important to think about, wait a second, 51 times and 6/10ths times 3 and 9/10ths is 20,124. That seems like a lot. So we're going to go back in and estimate. So we're going to count our place values. I have 1 digit in the place, 1 decimal in the 1 digit in the decimal place value in the first number, and 1 digit in the decimal place values in the second number, for a total of 2 decimal places. I need to now go back to my answer and scoop those 2 numbers to get us from the back end of this number, so at the 4, and I'm going to scoop to the left twice to see my new reasonable answer. And I scooped, I know it's a little cut off there, but I did scoop it twice to the left, and I got to an answer of 201 and 24/100ths. Now is the important part where I have to decide, is that reasonable? Is that a reasonable answer? Well, let me think about it. 51 and 6/10ths, that's pretty close to 52. And 3 and 9/10ths, well, that's pretty close to 4. So 52 times 4 is 208. Hey, that's pretty close to 201. So I'm now feeling comfortable about my answer. So you're really just working on your traditional multiplication algorithm, ignoring the decimal, pretending it's just 516 times 39. And then at the very end, realizing, wait a second, stop right there. It's not 516 times 39. It's 51 and 6/10ths times 3 and 9/10ths. And so putting those decimal place values back in there, I had 1 digit in the decimal in the first number, 1 digit in the decimal in the second number, for a grand total of 2, which I then scoop from the left of my final product. You don't worry about the decimal in any other area. You ignore it until the very, very end. You don't have to worry about it in each of the partial products. That's also important. And then once you have your answer, check. Is it reasonable? So your estimating is going to come in handy with this for sure. Okay. So not a lot to add on. A lot of the same as you saw last week. It's a lot of basic multiplication, so knowing your facts, knowing your standard algorithm, practicing as best you can with that, and then just putting in that added piece of reasonability. So counting your decimal place values and scooping them back in at the very end, and you will find success. As always, please reach out if you have any questions, concerns. They are the best way that you are going to learn. So please feel free to reach out and let us know what you need. All right, happy practicing.